Hi students, in this video we will see program to check whether the given number is prime number or not. So using while loop in the previous videos we have seen what is prime number. Now the same thing using for loop I am explaining you with the help of break statement. So that while loops program is available in the description, link will be shared. So please go through that program also. So what is prime number? What is prime number one? The number which is divisible by 1 and itself. 1 and itself is called as prime number. That is, every prime number is divisible by 1 and itself. Our using while loop, what we have discussed is we have counted that how many factors, that is with how many numbers that n will be divisible. If count value is 2, it is a prime, otherwise not prime. For example, let us assume that the number is 100. What is that number? 100. Now I want to check whether this 100 is prime or not. What was our previous logic? Let me explain you. 1, 2, 3, then so on, 10, then so on, 50, then so on up to 100. So what we used to do in the previous program is we used to divide this 100 with 1. 100 divisible by 1, s, count plus plus, that is count value we used to increase to 1. Then again we used to check 100 divisible by 2, s, count value becomes 2. 100 divisible by 3, no. 100 divisible by 4, s, count value used to become 3. 100 divisible by 5, s, count value will become 4. With 6, 7, 8, 9, so on to, we need to check with all the 100 numbers. After that, then we used to say that count value is already, it is more than 2, then it is not a prime. We used to discuss. We used to decide that it is not a prime number. Now if you observe carefully, once the number is, if the number is divisible by 2, already prime number means which is divisible by 1 and itself. Our previous logic was, even though it was divisible by 2, unnecessarily we are checking with the remaining numbers also. So what is prime number? Which is not divisible by any other numbers except 1 and itself. But unnecessarily, if it is divisible by 2, we are checking with 3, 4, 5 and all. But in this logic, what we do here is, if it is divisible by 2, we will stop at that point itself and we will decide that it is not a prime number. Now we know that so here the prime number is divisible by 1 and itself. Now what we want to do here is, in this example what we are going to do here is, we know that every number is divisible by 1 and itself. Now tell me, for 100, what is the greatest number which can divide 100 other than 100? 100 divisible by 90? No. 70? No. 60? No. 50? Yes. So after 50, no other number can divide 100. So what is the least number? 1, it will already divide. 2. What we do in our logic is, we will divide from 2 to half of this number, that is 100 by 2 is 50. We will divide from 2 to half of that number. If it is divisible by any of the numbers, it is not a prime number. If it from 2 to half, if it is not divisible by any of the numbers, then we call it as a prime number. So what we are doing here, half of the iterations we are reducing. If it is prime also, we are reducing half of the iterations in this logic. So 2 to half we will take. Now please observe carefully. Now accept a number from the user for I equals to 2. We are starting from 2. Then I less than or equal to n by 2, because half the iterations are sufficient. Then after coming out of the loop, then check here, 2 to half, if it is divisible by, if n divisible by any of the numbers, no need to check with other numbers, simply break. Please observe carefully. So we'll starting from 2 to 1, anyhow every number is divisible by 1, so we will not check. 2 to half, if it is divisible by any of the numbers, through break we will come out of the loop. Through break will come out of the loop. After coming out of the loop, it can come out of the loop in two ways. One is through break, the other one is through when the condition becomes false. If the condition becomes false, means it is not divisible by any of the numbers from 2 to half, then I value will be greater than half. I value will be greater than half. So what we need to do here is, if I greater than n by 2, simply display the message printf percentage d is prime number. Percentage d is prime number. Display n here. Otherwise, if it is less than half means through break it comes out of the loop. Then you display the message printf percentage d is not a prime number. Not a prime number, comma n. This is to check whether the given number is prime number or not. Now let us run this particular program. Now compile and run the program. Enter 100. 100 is not a prime number. Now if you want to check when it comes out of the loop, so there you can see I value also. If you see the I value, I will display I value. At what point it will stop, you can come to know. Printf /n comma I. So save your program, then compile and run the program. Enter 100. When it has come out, when I value is 2 only, it has come out, meaning it will not go up to 100. In the previous program it used to go up to 100. Now here it will stop at this point itself. Now suppose you enter 101. Yes, 101 is prime number, because it is not divisible by any of the numbers from 2 to half of that number. 2 to half, it is not divisible by any of the numbers. So we call it as a prime number. This will give you the logic to check whether that number is up to how many iterations it has been done, up to which number it has been iterated. Thank you for watching. For more videos, please like, share and subscribe.